In this video, I will try to recall for you first order separable differential equation. A first order differential equation has this form. You have x, which is the unknown. X is a function of t. The derivative in t of x will be equal to a function f, which is given. F is a function of t and x. A separable equation is an equation in which f can be written like the product of two functions, h of t and g of x. So in this case, you will have an equation of the form dx over dt, or x prime, is equal to ht gx. And x is the function that you want to solve. H is given, g is given. G is a function of x, but g is given, and you want to solve for x. Now, in this case, how do you solve x? You can see that here, x and g are separable in the sense that you can pull x to one side and t to the other side. To be more precise, the first thing that I do is that I divide gx to the left hand side. I'm gonna have 1 over gx dx dt is equal to ht. The next step that I'm going to do is that I integrate both sides with respect to t. The left hand side will be 1 over g dx over dt, and I integrate. Alright, so dx over dt is x prime again. The right hand side will be the integral of ht dt. Finally, I will have on the left hand side an integral in terms of dx, and on the right hand side I gonna have an integral in terms of dt. Now, let us consider one specific example. I want to solve this first order differential equation. X prime is equal to x squared cosinus of t. What I do is I divide x squared to the left hand side, so I have dx over x squared. I multiply dt to the right hand side, so I have cosinus dt. In this case, x and t are separated. This is why this is called a separable equation. Now what I do is that I integrate on the left hand side with respect to x, and I integrate on the right hand side with respect to t. The antiderivative of 1 over x squared is minus 1 over x. The antiderivative of cosinus of t is sinus t plus c. So, solving this equation, you can find the explicit form of x. Now, let us consider another equation. You have x prime is equal to x times 1 minus x. This equation is separable because you can group x to one side and t to the other side. So I multiply dt to the right hand side, and I divide x 1 minus x to the left hand side. What I do is that I integrate both sides. In x, I'm gonna have an integration of 1 over x 1 minus x dx, and I'm gonna have an integration of dt. The integration of dt will be 1. To do the integration of 1 over x 1 minus x, we do the following method. You're gonna write 1 over x 1 minus x as the sum of a over x plus b over x minus 1. ab will be the constant that we choose later. Now you multiply both sides with x minus 1. I'm gonna have minus 1 is equal to a x minus 1 plus bx. Now putting x to be 0, you're gonna have minus 1 is 0, a 0 minus 1 plus 0, so a is 1. Putting x to be 1 here, so a 1 minus 1 will be 0, you're gonna have b is minus 1. Right, so finally I have a is 1 and b is minus 1 by putting x to be 0 and x to be 1 into the equation. So now you're gonna put a here to be 1 and b here to be minus 1. This integral will become this integral. This integral will be the same with this integral. Now you take the antiderivative of 1 over x, you get log of x absolute value. You take the antiderivative of x minus 1, you get log of x minus 1. And the antiderivative of 1 will be t plus c. You put things together, you're gonna get log of x over x minus 1 is t plus c. You solve this equation, you get x over x minus 1 is e to the t plus c. C is a constant. Which means that x over x minus 1 is e to the c, e to the t. C is an arbitrary constant. You solve this, you get x over x minus 1 is plus or minus e to the c, e to the t. Now, I'm gonna put e to the c to be a constant k. It is an arbitrary constant. It can be positive or negative. And you solve it, you get this solution. Right. Thank you for your attention.